Opening. Balance the following chemical equation. Please pause the video at this time and see if you can do it. Okay, we're back. Was that easy? Was it difficult? Well, I'm going to show you exactly how to do it today. But first, let's have a review of yesterday's lesson. So we looked at this equation. This is one of the equations for iron rusting. Iron actually can combine with oxygen to become iron 2 oxide, or it can become iron 3 oxide. And we'll talk about both of those reactions today. All right, when you look at an equation like this, you will notice these large numbers, the 4, the 3, and the 2. The 4, 3, and 2 are coefficients. They multiply things in the equation. So let's just review what a coefficient is. Right now, you and I are breathing O2. That would be 2 oxygens bonded together. This is what O2 looks like, and this is how we represent it in a chemical equation. If I put a coefficient in front of the O2, it becomes 2O2, and it looks like this. And 2 times 2 is 4, and we have 4 oxygen atoms. Just a review from yesterday. If we have 3O2, it looks like this. 3 times 2 is 6, and we have 1, 2, 3, 4, 5, 6 oxygen atoms. Even if I didn't see the picture of what 4O2 looks like, I can predict that it's going to have 8 oxygen atoms because 4 times 2 is 8, and you can see 1, 2, 3, 4, 5, 6, 7, 8. All right, here's something new, nitrogen dioxide. That is a pollutant. That's something we want to have less and less in our atmosphere. Nitrogen dioxide is a covalent compound. It's NO2. So the blue here represents nitrogen, and the 2 represent oxygen. And nitrogen and oxygen have very similar atomic radii, so this is a good picture of it. If I were to put a coefficient right here, let's say I put a 2, I would have 2 of them. And now we have 2 nitrogens and 4 oxygens. Remember that this coefficient doesn't just multiply the nitrogen, it multiplies the whole molecule. So nitrogen gets doubled, and the 2 oxygens in the molecule also get doubled. So 2 nitrogens and 4 oxygens. Let's see that. We have 1, 2 nitrogens, 1, 2, 3, 4 oxygens. And this is what 3NO2 would look like. 3 nitrogens and 3 times 2 is 6, 6 oxygens. 1, 2, 3, 4, 5, 6. That's how coefficients work. It's an essential thing that you need to know in order to balance chemical equations. So let's go over some vocabulary. When we look at a formula like this, it's separated by the arrow. To the left of the arrow are the reactants. These are the 2 things that are going to react. They're going to form a chemical reaction. And to the right of the arrow is the product. Sometimes the product is just one thing, sometimes it's many things. These are the reactants, this is the product. And this arrow here means yield. It also means produces. So when we say an equation, it's not exactly an equation, there's no equal sign. Instead we have this arrow, which means produces. So these 2 things produce this. 4 moles of iron and 3 moles of dioxygen yield or produce 2 moles of iron 3 oxide. Oh, and this is how you would write it out. Pay attention to this because I'm going to be asking you to interpret equations like this in written form. So this would be read as 4 moles of iron and 3 moles of dioxygen yield 2 moles of iron 3 oxide. I hope you remember what these Roman numerals mean. That is the oxidation number of iron. It's not the number of iron because we have 2 irons here, and times 2 is 4. But this is the oxidation number of that particular iron. All right, sometimes in a chemical equation you're going to see letters in parentheses. This S means that it's a solid. This G means it's a gas. And sometimes you'll see this symbol. Some people think that's an I. Actually, it's a lowercase l, and it means liquid. So sometimes we want to describe things in terms of solid, liquid, and gas. And the fourth abbreviation you'll commonly see is AQ, which stands for aqueous solution. That means that it is dissolved in a solution, usually dissolved in water. All right, now that we've gone over some vocabulary and we reviewed what a coefficient is, it is time to balance some chemical equations. What was the opening today? Oh, okay, you might have had a little bit of difficulty with that. Let me show you how to do it. So we have gold. We're going to add it to H2S, and we're going to produce gold 1 sulfide, and we're going to also have a leftover. We're going to have dihydrogen. So we're going to produce this interesting compound of gold, an ionic compound, and we're going to have leftover hydrogen gas. Not loose hydrogen, but hydrogen that's bonded to hydrogen. We call it dihydrogen. So let's look at how to solve that. You need to solve something like that on paper. So the first thing you need to do is take an inventory of what you have. And you need to write down that there's gold, there's hydrogen, and there's sulfur. And we're going to count how much of each that we have. So this arrow separates the reactants from the products. In terms of products, we're going to have the exact same thing. We're going to have some gold, we're going to have some hydrogen, and we're going to have some sulfur. And I know what you're thinking. You're like, why did I write it AUHS when in the formula it's AUSH? Well, it doesn't matter too much what the order is, but just to keep it organized, to allow it to be easier on the mind, always have this inventory list resemble this inventory list. So I wrote AUHS here, I'm going to write AUHS here, and this allows me to compare the values, which is what we're going to be doing. So how much gold do we have here? We have 1 mole, or we could just say that we have 1 atom of gold. We have 2, let's say it's atoms, 2 atoms of hydrogen and 1 atom of sulfur. On this side, we have 2 atoms of gold, 1 atom of sulfur, and 2 atoms of hydrogen. And then we say, is the equation balanced? And the answer is no. These numbers and these numbers are different. The law of conservation of mass says that when I do a reactant like this, I'm not going to end up with more gold. When I do a reactant with this, the amount of gold on this side is going to be the exact same as the amount of gold on that side. Just imagine if we could produce gold by combining it with this. Well, we can't do that. That would defy the law of conservation of mass. So I need to put a coefficient somewhere to get this to be balanced. Do I need to put a coefficient that changes the value of sulfur? No, sulfur is 1 here and sulfur is 1 here. It looks like that's okay. How about changing hydrogen? Well, we have 2 hydrogens on this side and 2 hydrogens on that side, also balanced. But here we have extra gold. We have 2 golds here, so we need to have 2 golds on this side. I'm going to put a 2 here, and that changes this value to a 2. Now we have 2, 2, and 1 on the reactant side. We have 2, 2, and 1 on the product side. We'd say now it's balanced, and it's just because we added this 2. And if we're interested in what coefficients we have a 2 here, we have a 1 here, we have a 1 here, and we have a 1 here. In chemistry, you don't need to write the ones, but I'm just going to do it this time so that you can see them. We have a 2, a 1, a 1, and a 1, and that is the coefficients that make this work. So let's see if I got it right. Here's the answer. It's 2, 1, 1, 1, and that balances the chemical equation. All right, let's do another one. I said that iron and dioxygen doesn't always combine to form Fe2O3. Sometimes it combines to form FeO. So can we balance this chemical equation? Let's set that up right here. And again, the first thing you do is you write an inventory list. And a lot of people like to take shortcuts, and I'm going to recommend you do not do that. Write it very neatly and very formally. Try not to do it in your head. Resist that temptation. It might be a little bit faster, but when you get to really complex ones, you're going to regret it. So this arrow represents our reactants and our product, just one product here. And just as I wrote iron and oxygen on this side, I'm going to write iron and oxygen on this side. And we're going to take an inventory list. We have one iron here, two oxygens here. We have one iron here and one oxygen there. This is not balanced. So we got to do something about the oxygen. Well, there's no way I can turn a 2 into a 1. Not by adding coefficients, and the coefficients should always be integers, by the way. But we can turn this 1 into a 2. If I put a 2 here, that turns oxygen into a 2. But remember, when you put a coefficient here, you are multiplying the entire molecule. So that means iron gets doubled also. So that's too bad, because now it's not balanced because of iron. So I have a 2 here, I only have a 1 here. Let's put a 2 here. And that changes the value of iron to 2. Now we have 2 and 2, 2 and 2. Because I wrote it neatly, I can see that the iron is 2 and iron is 2. Oxygen's 2, oxygen's 2. I can look right across and see that, yes, I did it. This is balanced. What are the three coefficients in this balanced chemical equation? It's 2, 1, 2. That balances the chemical equation. And let's see if I got it right. Yep, 2, 1, 2. That is the answer. So iron and oxygen can react in two different ways and form two different molecules, and you've seen both of them today. That is the introduction on how to balance a chemical equation. Hope you enjoyed it. The end.